dreaming of warp speed, from childhood fantasies to scientific hurdles. When I was a kid, I used to imagine what it would be like to travel through space, visiting different galaxies and planets. But then my physics teacher would explain the vast distances of celestial bodies with such enthusiasm, and I'd think, man, you need one seriously fast spaceship to go that far. Imagine zipping across the galaxy in seconds, planet hopping like you're flipping through TV channels. Sounds like something straight out of a sci-fi flick, right? But what if I told you the biggest hurdle to making that a reality isn't a lack of spaceships, but something far more fundamental, something that challenges the very speed of light itself? Get ready to uncover the truth behind Star Trek's famous warp drive and find out why. For now, it's still an impossibility, but is it impossible forever? Ever since the crew of the Enterprise showed us the wonders of the universe, one question has echoed in the minds of scientists and enthusiasts alike. Can we actually build a warp drive? The idea of distorting space-time to travel faster than light is captivating, but it clashes with one of the cornerstones of modern physics, Einstein's theory of relativity. This theory, proven countless times, unequivocally states that nothing with mass can reach or exceed the speed of light in a vacuum. So, have a Star Trek pull off this feat, they propose a concept called warp space, which doesn't violate this law, but rather skirts around it. But what does that mean in practice? And what are the monumental challenges science faces in turning this fiction into reality? In this video, we'll dive deep into the physics behind warp drive, understand why it's so complex, and discover if humanity is, in fact, on a path that will one day take us to the stars at unimaginable speeds. Unraveling warp space, the basis of a warp drive, as imagined in Star Trek and studied by theoretical physicists, isn't about accelerating a ship to the speed of light. That would demand an infinite amount of energy, which is a total non-starter. The core idea is to distort space-time itself. Picture space-time like a stretched-out bedsheet. If you put a bowling ball in the middle, it creates a dip. Warp space would do something similar, but way more intricate. The most well-known concept for warp space is the Alcubierre Metric, proposed in 1994 by physicist Miguel Alcubierre. Simply put, the idea is to create a warp bubble around the ship. This bubble would compress the space in front of the ship and expand the space behind it. The ship itself would remain stationary within this bubble, but the space-time bubble would move at superluminal speeds. It's like you're on a treadmill, moving super fast, but you're just walking in place. The ship isn't moving faster than light through space, but the space with the ship is contracting and expanding, effectively taking it from one point to another much faster. However, the Alcubierre metric comes with some formidable challenges that currently keep it squarely in the realm of science fiction. First off, it requires the existence of exotic matter with negative energy density. Think of normal energy as something that pushes outwards, like gravity pulling downwards. Negative energy would do the opposite. It would have an anti-gravitational effect, pushing upwards or repelling. This is crucial for compressing the space in front of the ship. Currently, the only known form of negative energy is the Casimir effect, which occurs on microscopic scales and in tiny amounts, producing negative energy on a large scale. Enough to move a ship is way beyond our current technology and perhaps our physical understanding. Second, the amount of energy needed would be astronomical. Initial estimates pointed to the mass of an entire planet converted into energy, while more recent studies have reduced that estimate to the mass of a cargo ship. It's still an unthinkable amount of energy for current technology. Think about the difficulty of getting the energy to launch a rocket to the moon, and then multiply that by trillions. Third, there's the instability problem. Creating and maintaining a warp bubble would demand incredibly precise control over space-time. Small fluctuations could have catastrophic consequences, disintegrating the ship or even creating black holes. It's like trying to walk a tightrope while the ground beneath you is twisting and violently swaying. And let's not forget the paradox. What happens to what's in front of the bubble? If you're compressing space, anything in your path, asteroids, cosmic dust, even subatomic particles, would be hit by this compression wave at incredible speeds, releasing colossal energy. This would not only destroy what's in the way, but possibly the ship itself. Despite these monumental obstacles, research into warp space isn't completely stalled. Physicists continue to explore the nuances of the Alcubierre metric and other theoretical ideas. The goal isn't simply to replicate fiction, but to understand the limits of physics and if there's Perhaps some loophole we don't fully comprehend yet, because the greater the challenge, the greater the perseverance to achieve it. Humanity is always looking to evolve, and I have no doubt that one day someone with a crazy idea might just crack this nut. The future of interstellar travel, a dream or a destination? So, we come to the million-dollar question: is warp space an unattainable dream or a distant future goal? The reality, right now, is that building a warp drive like the one in Star Trek is way beyond our technological capabilities and even our current understanding of physics. The challenges are immense. The need for exotic energy quantities that far exceed anything we can generate, and the sheer complexity of controlling the very fabric of space-time. However, the history of science is filled with impossibilities that became reality. There was a time when flying was considered impossible, when long-distance communication was pure magic. Every time a theoretical or technological barrier is raised, human curiosity is ignited, and brilliant minds start looking for solutions. While the Alcubierre warp drive presents almost insurmountable obstacles, the quest for faster methods of interstellar travel continues. Scientists are exploring other ideas, like quantum teleportation for information, not for people, and a deeper understanding of gravity. Who knows, maybe one day, a new discovery in quantum physics or cosmology will reveal a completely different path that we haven't even imagined yet. The truth is, science fiction often serves as a beacon, inspiring generations of scientists to pursue what seems impossible. Star Trek's warp drive may not be a reality in our time, but its idea continues to drive research and make us dream of a future where the stars are no longer distant points, or reachable destinations, and who knows, the next big discovery too. Make that possible might just be a curious mind away. If you're also passionate about the mysteries of the universe and want to unravel more curiosities about space and Earth, don't waste any time. Click the subscribe button below and hit the bell icon so you don't miss any of our upcoming videos. And now, I want to hear from you. Do you believe we'll ever build a warp drive? Let me know your thoughts in the comments. Your participation means a lot to us.